Alright guys, so now we're going to talk about molarity, which is the other form to talk about concentrations. We talked about concentrations in form of percent when it came to mass over mass, volume over volume, or mass per volume, those kind of percentages. And we talked about it in forms of a fraction when it came to parts per million and parts per billion. So now we're going to talk about concentration in the form of molarity. So molarity is the word that we use to describe moles per liter. So the quantity of solute in moles divided by liter. So remember that moles is all around and we use it to describe practically everything. All right, so the uniform molarity is basically capital M, which stands for moles per liter. We could rearrange this in the form of, if we wanted to know how many moles are inside of a solution, and then we could say moles is equal to molarity times volume. And we could rearrange it again to find the volume. And we could say volume is equal to moles divided by molarity. So 3 easy little ways to use this little problem and solve for either molarity, moles, or volume. All right, so let's go ahead and look at an example. First one, in an aqueous solution with a volume of 9.41 liters, it contains 412.3 grams of dissolved potassium chloride. What is the molarity of this solution? So in this case, we're looking for molarity. So molarity is equal to X. It is unknown. Our volume is equal to 9.41 liters. And our mass is given to us. So our solute is given to us in grams of 412.3 grams. Now, remember, molarity is moles per liter, and we're giving it to in grams. So using basic stoichiometry, we have to convert grams into moles. And yes, as you recall, we have to use the periodic table and we have to get the molar mass. So use molar mass. And in this case, it's the molar mass of potassium chloride. Okay? So every single time you have to convert from grams to moles. Make sure you're using that molar mass. All right, so I'm going to cheat right here. All right, there we go. This calculated the molar mass for me. So the molar mass of KCl is equal to 74.55 grams per mole. I just didn't want to look it up on a periodic table. And if you don't have, like right here, you're trying to do your work, look it at a periodic table and add them up together. We already know how to do that. All right, anyways, let's go ahead and convert. So we have 412.3 grams and bring this unit down. So we're left with 74.55 grams of KCl here. This allows grams to cancel out with grams, and we just do a simple division. So 412.3 divided by 74.55 gives us 5.53. Okay, and this is going to be the number of moles of KCl. Well, we only did one tiny little step here. So now we're going to go ahead and plug it into our equation. So the first step was find molar mass, which we just did. And now we're going to plug it in. So leave some space here. Molarity is equal to 5.53 divided by the volume of 9.41. I'm going to take that number and not divide it, multiply it by, is it multiply? No, divide. Oh my goodness. I'm going to divide it by 9.41, and that gives me 0.5877. I want to represent my answer in 3 significant figures because this is in 3 and that one's in 4, so we always do the least amount. So that 5.877 is going to round to 5.88 molarity of KCl. So that's the concentration of potassium chloride solution. All right, let's go ahead and see how we did. Step 1 and step 2, calculate it. Perfect, step by step. All right, let's go ahead and look example number 2. How many moles of hydrochloric are in 250 milliliters of a 6 molar hydrochloric solution? All right, so molarity in this case is 6.0 of hydrochloric. My volume is given to me as 250 milliliters, and my moles is unknown. It's X. So do you guys see the first step that you have to do in this problem? Yes. The first step is to convert 250 milliliters into liters. So you have to convert that into liters. Okay? And quite simple. I'm going to do it over here. 250 milliliters, simple conversion. In 1 liter, there is 1,000 milliliters. So we're just dividing this, and we get 0.25 liters. All right, now we can go ahead and solve. So we're solving for moles, so we're using this equation right here. Moles is equal to the molarity times our new volume. So therefore, moles is equal to 6 times 0.25, and I get 1.5 moles of HCl. All right, let's check it out. Always like to verify just to see how I did. Here we go. So we converted our milliliters into liters. Job well done there. And now we're going to put those numbers into our equation, which is mole is equal to molarity times volume. Multiply them together, and we end up with 1.5 moles of hydrochloric acid. All right. Well, what if we want to prepare a solution, right? Does 1 mole plus 1 liter of water equal 1 molar solution? Not really, actually. If you guys recall on the last one that we did, we didn't really have an exact quantity. So we added our stuff together to find out the mass of our solution. So back in our first video, we said if you add 20 grams of sodium chloride to 500 milliliters of water, what's the mass of our solution? Well, so the mass of our solution was 500 plus 20, which gave us 520 grams of solution. So therefore, this is not an exact quantity, right? We're not going to get exactly 1 molar solution. And that's because when we add things together, if you put the exact amount of water first before putting in your solute, you're going to end up with more. So the way we solve that in the lab and anywhere that we're at, you're going to get your container and you're going to fill it to like maybe halfway. So partially fill your container, and you're going to add your weight of whatever mass you want inside of that container. You're going to shake it up really, really well until it dissolves, and then you're going to dilute it. So you're going to add more solvent until you get to your quantity. Now this right here is a round bottom flask. And a round bottom flask only has 1 graduation. So that means it measures an exact quantity. So remember, add your solute, add water partially, mix it, and then add the correct volume to it. So that way you can know exactly how much solution you actually have. So let's look at how we prepare diluted solutions. Okay. So remember, a diluted solution means you have more solvent than you do solute from your original concentrated solution. So in a dilute solution, the number of moles don't change. So the number of moles stays the same. So the way you increase volume is by adding more solvent. Number of moles stays the same. Therefore, moles is equal to moles. The initial moles we start with is equal to the final moles we end with. And if you guys remember the equation we just did, we said moles is equal to molarity times volume. So if mole initial is molarity times volume and mole final is molarity times volume, we're going to plug them in and we end up with Molarity times volume equal to your final molarity times volume. How much did it change to? How much were you able to dilute it with? So this is your initial concentration and initial volume, and this is going to be your final concentration and your final volume. All right, so let's look at this problem here. You have a 25 milliliter of 10 molar solution of potassium hydroxide. To this, you add enough water to make 500 milliliters of dilute solution. What is the molarity of your final solution? So let's go ahead and do an example. So we're using the equation M1V1 is equal to M2V2, or mass initial is equal to final. Okay. So we have our initials, so M and V initial. And you know what? I like to write everything out. And so I'm going to just put final, or you could put the number 2 if you like. Volume final. And let's see what we have. So we have 25 milliliters and 10 molar solution. Okay, and this is molarity of potassium hydroxide, so KOH. To this, we add enough water to make a 500 milliliter solution. So we added water, and now we have a 500 milliliter solution. What is the molarity of the final solution? So this is X right here. Now, we have our equation, MV is equal to MV, 1122. Okay. We have everything we need for the initial, and we're just missing the M for the final. So let's go ahead and solve for our molarity final before we put everything else in. So therefore, MV1, like this. So this is how we're going to solve for our new molarity. So we diluted the solution. What is the new molarity? What did it change into? Okay, we're going to go ahead and plug our numbers in. Now, one thing I want you guys to notice is that these units are in milliliters. They're in milliliters. However, the units are going to cancel themselves out. Both of these units will cancel themselves out, so we do not need to change that into liters. Okay, you could leave them in milliliter state. All right, so 10 times 25 divided by 500 is equal to M2. 10 times 25 divided by 500 is equal to 0.5 molarity of potassium hydroxide. So this is what this diluted solution is. We went from a 10 molar to a 0.5 molar solution. Right? So that's actually very dilute. I'm just double checking my math. It looks like I did it okay on my calculator. Let's see how I did it actually in person. Okay. 0.5 molar of potassium hydroxide. So as you can see, when you're solving these problems, you really want to write everything out first. Put your equation down, isolate the variable, and then plug in the number. So that way you don't get confused as to what you need to solve with. All right, so now we're going to do a second example. In the second example, example number 2, it says, starting from a 12 molar concentrated hydrochloric solution, you need to prepare 180 milliliter of 1 molar aqueous hydrochloric. What volume of concentrated hydrochloric do you need? Let's go ahead and write everything out. M1, V1, M2, V2. All right, so M1 is starting from 12 of hydrochloric. You need to prepare 180 milliliters of this. So we don't know what V1 is because it says what volume of concentrated do we actually need. And this is actually more common type of problem right here when it comes to preparing solutions in a lab is what's the volume do we need? We have this much is our concentrated, right? How do we dilute it to prepare solutions inside our lab? Okay, so our molarity that we're trying to create is a 1.0 molar solution, and we want 180 milliliters of the solution. M1V1 is equal to M2V2. We're solving for V1, so we're going to divide both sides by M1. So therefore, V1 is equal to M2V2 over M1, right? Because those cancel out. Let's go ahead and solve. Now we're going to notice again that this is in milliliters, but that is completely fine. It didn't state that it wanted it in liters or anything like that. So we're going to just leave it in milliliters to find out what the quantity is that we're going to need. And the reason why is because here molarity and molarity, even though these are in moles per liter, they're both going to cancel themselves out. So we're going to go ahead and solve our problem. V1 is equal to M2, which is 1. And you know what? I'm just going to write M so that you guys could see the units cancel out. And V2, 180 milliliters, divided over M1. And that is 12 M. Okay. Molarity cancels out with molarity, and we're left with milliliters. That's what we want. So we're going to take 180 and divide that by 12, and we get 15. Okay. So this is equal to 15 milliliters of hydrochloric. So we need very little of that concentrated solution in order to make a 1 molar aqueous or 1 molar molarity of hydrochloric acid solution. 15 milliliters is all it takes. Now I want you guys to think about how concentrated that can be, right? A 12 molar concentrated solution can cook meat, right? So it starts burning your meat, right? Because it's very acidic. A 1 molar solution can irritate your skin, right? And when you have face creams or things like that that do have anything like hydrochloric, it's usually like a 0.005 molarity, right? And that's enough to help peel off like the first 2 layers of your skin, right? It's just the normal stuff that we get at Walgreens. So very, very little of this concentrated solution is all that's needed. Right, let's move on. Okay, so molarity, remember, is moles per liter. And dilutions, we use M1V1 is equal to M2V2 to calculate these. All right, so when we talk about electrolytes, I'm actually going to do that in another little video for you guys. Ciao.